Okay, so now we're on question 50 and we get to use our graphing calculator a little bit. So we're going to graph this one on a calculator. Now this one is exceptionally easy to graph without the calculator, but you will have calculator exercises also. Learning how to use your calculator is very important. We already know what this one looks like, right? If we're going to graph it without the graphing calculator, it would have a -4 y-intercept. 1, 2, 3, 4. And then it would go up 3 over 2, 1, 2, 3 over 2, and 1, 2, 3 over 2. So then we draw a line, and we know that's what it should look like, okay? But let's graph the same thing with our graphing calculator because some of you are still catching on to your graphing calculator. So the first thing we're going to do is, hopefully you know what that is because I'm going to put this down. We're going to enter in the problem into our graphing calculator. So I'm going to put that down for a minute and I'm going to show you my graphing calculator screen. So the benefit of the videos is that I can get right up and show you what I'm doing. So I have pressed the Y equal button to get where I am right now. And so now I'm going to enter in this equation. So y equals 3/2 x. So I'm going to put 3 divided by 2, and then I'm going to do an arrow over because I want to be out of the 3/2 x. I don't want it to go in the denominator. And then I'm going to put my x. Okay, the other way that I can do that is, I think probably maybe clearer. Let's put a parenthesis around the 3/2. Let's do it that way. Divided by 2, let's do the parenthesis, and then we won't have any doubt that the whole 3/2 and the x is not going on the denominator. Okay, so then I'm going to put a -4. So I'm going to use minus, not my negative button. Okay, so now I should be able to graph that. Now, the reason this is looking like this is because I still have old data in here. So what I'm going to do is I'm going to clean up my window, which is not what it should be. It should be -10 to 10, and then a scale of 1, and then a -10 to 10, with a y scale of 1, and now when I graph it, those points won't show up at all because they were way up above, like at 50. So I've cleaned up my window. I still need to go in there and get those old points out of there, but they're not going to bother my graph right now. So there is a graph of the line, and here was our graph. It does look like it's doing what it's supposed to, okay? It is crossing at -4, which is very difficult for you to see, but it is matching the graph that we did on the paper. So that is number 50, okay? So number 60 here is now we're graphing, but they want us to graph both using the regular window that we just put in and then using, so look at this, this is a y-intercept of 24. So we're not going to see our intercepts on our regular -10 to 10, -10 to 10. So we're going to have to change the window. But what they're trying to get us to see here is just give us some calculator experience. They want us to first use the normal window that we just put into this calculator and then use this suggested window. Okay, so let's put this one in. Y is equal to -2x plus 24, and I'm going to clear the other one out of the calculator. So I'm just going to press clear and clear away that one right there. And then I'm going to put in -2y. So now I want to use this button for my negative because it's not a -2y, it's a -2, and then, excuse me, x. All right, -2x, and then plus, so I'm going to use this plus, and 24. Okay, so -2x plus 24 looks right to me. So now we're going to graph it. But remember, we just have a standard grid in there. And since our graph only goes up -10 on the x, +10 on the y, -10 on the, I said that wrong, -10 on the x, positive 10 as the maximum x, and then our y is going from negative 10 to 10, we see only a tiny little corner over here of the graph. Can you see the graph? It's hard to see what you can see because, yeah, you can see just a very tiny little corner has a graph in it. So now we're going to go to window. So we're going to go to window here, and we're going to put in their required window. Their suggested window is negative 15 to 15 on the x, negative 10 to 30 on the y, and that 30 is going to get us up past our y-intercept, isn't it? And then an x scale of 3 and a y scale of 5, which is going to bring our graph, it's going to shrink it in to where we can see more of it. So let's put those in on our calculator. So we're going to put here, instead of a negative 10, I'm going to put a negative 15. And then instead of a 10, I'm going to put a 15. And then the x scale is going to turn to a 3. And then I'm going to put in a negative 10, which is already there, and a 30. And then a y scale of 5. So I've cleaned up my window to be what they said the window should be. Okay, hopefully you can see that. So now I'm going to graph. And now I can see both of the x and the y-intercepts. The x-intercept and the y-intercept are now visible in my screen. So that's a good graph, right? If I can see my x and my y-intercept, I have a much better idea of my line. So when you're graphing a line for me, you want to do your very best to show me your x and y-intercept. Now, if your x and y-intercept falls off the grid I give you, you can always change your scale, which is what we did here. So if I gave you a line that's not going to cross, so you can take the grid I give you and you can change the scale to make it be what you want it to be. Okay, so that one was number 60. Number 70, we are to find the distance between these. I lost my little marker. What did I do with it? Okay, so now we're going to find the distance between these points. Okay, so we've got an x and a y and an x and a y, and our distance formula, remember, is based on Pythagorean Theorem, so that this distance between these two is going to end up being x2 minus x1, and this distance between these two is going to end up being y2 minus y1, like the development I showed you on the board. So if I want to find this distance d, I'm going to use my Pythagorean theorem, which says this one squared, so x2 minus x1 squared, plus, and then this one squared, y2 minus y1 squared must equal d squared. D squared. Okay, so now I don't want d squared, I just want d. So d is equal to the square root of all of that, which is the square root of the difference in the two x's. Remember, it does not matter which way you get those because you're about to square it. And the difference in the two y's squared. So now let's do our problem. So we're going to have this one minus this one. So negative 4 over 25 minus negative 13 over 25, quantity squared, plus, then I'm going to take my, okay, now I did my y's instead of my x's, but does it matter? It doesn't matter which one I do first. Okay, I could do my y's first or my x's because they're all going to be added together. So I did my y's instead of my x's. So don't let that confuse you. It turns out to be the same thing. So now, since I just did my y's, I'm going to do my x's. So I'm going to take this one. Dropped my marker. I'm back. Okay, so 1/2 take away 1/2. Okay, and that's going to be squared. So what are these 2 points? These 2 points have the same x. So these 2 points are just 2 y points that we're going to subtract, okay, because they're both on the same line. This is going to be a what? X line, so X lines are vertical. So these two are right above each other, so we're really only going to have to do that. We could find the distance linearly without ever doing this, but we'll keep on going. Okay, so this one is going to be a plus 13, and then the 4 is going to be a 17 over 25 squared, and then this one adds 0, so we're just going to get this right here, which is just going to be 17 over 25, and that was number 70, and that is not the answer. Let me check here. Let me see if I copied the problem right. All right, let's see what I did wrong. Sometimes that happens. Okay, I did the y's first, so I did this one minus this one. Oh, I got it. I see. I added wrong. Oh, I'm so sorry. So this one is going to be what? The plus, but the plus and the minus are opposite signs. That's going to be a 9. Okay, and then that's going to be a 9. My bad. Okay, I can't add and I can't subtract. So that should have been just 9 over 25, which is the correct answer. Okay, so let's go to the next one, which is 3 points that we're going to see if they do form a right triangle or if they don't form a right triangle. So on this one, we're going to perform the distance equation on each one of these segments. So if this were point A and B and C, we're first going to find AB, and then we're going to find the distance AB and the distance BC between those two, and then we're going to find the distance of this to here, so AC. So we're going to find each one of those segments and their distance. All right, so the distance between A and B, we're just going to use our distance formula, which is difference between these. So these are 2 steps apart, right? 1 and -1 are 2 steps apart on the number line, and we're going to square that. And then 2 and -3 are 5 steps apart on the number line, and we're going to square that. Okay, and then we're going to take the square root of that. So that's going to wind up being 4 plus 25 is 29, and that's going to be 29 square rooted. Okay, so we get the square root of 29, and I'm just going to check my answers as I go. Oops, they don't have all those answers in there, so I hope I got it right. And then here, we're going to do BC. Okay, so the distance between a -1 and a 9 is actually 10. So we got a 10 squared. And the distance between a 6 and a 2 is a 4. Okay, so the square root of all of this will give us the distance between these 2 points, which is going to be the square root of 116. Okay, and the square root of 116, I can pull out and simplify. I can pull out a 4, I know that much. If I pull out a 4, I'll have 25 plus 4 is 29. So 4 squared of 29. And then the 4 becomes a 2. Square root of 4 becomes a 2. Okay, and then lastly, we're going to find the distance between these two. Okay, so between a 9 and a 1 is 8 steps squared. And the distance between a 6 and a -3 is 9 steps squared. Remember, you don't care whether you're getting a +9 or a -9 because you're squaring. So then that's going to be the square root of 64 plus 81. And when I add those together, I get the square root of 145. Okay, and then let's see, I'm trying to think of what I can pull out of that. I know I can pull out of 5. Let's factor that, 145. So I'm going to pull out a 5, and that's going to give me a 245, 9. Okay, so that's going to be a square root of 5, square root of 29. So that does not simplify. Okay, so now let's apply our Pythagorean theorem to all of these. Okay, so basically my Pythagorean theorem is going to square each one of these, And since that one was square root of 16 and that one was square root of 29, this one is my hypotenuse, isn't it? So I'm going to take this one squared, which is going to end up being 29, plus this one squared, which is 116, equals this one squared, which is 145. So then I add them together, and I get 15, and I carry, and yes, it is true. Therefore, I'm going to say that these are the vertices of a right triangle. Okay, so that one was number 80, and number 90 is a midpoint problem. So remember, when we're doing a midpoint, we're going to take x1 plus x2 divided by 2. It's an average. Y1 plus y2 divided by 2. And we're going to make our new point. And it will be exactly halfway in between those. So I add together my two x's and I get a 0. And a 0 divided by 2 is still 0. And I add together my two y's and I get a 0. And so 0, 0 is my midpoint. Now let's look at it. So 1, negative 2. Okay, and 0, 0, and negative 1, 2. It looks like it is exactly the midpoint. Down 2 over 1, down 2 over 1. They are on the same line. Okay, so just add the two x's together, divide by 2, add the two y's together, divide by 2, and there you have it. So that's number 90, and we just have a couple left for this video. Okay, so we're almost to the finish line here. We're on problem 100, going by tens, and this is a circle. So we're given a center and we're given a diameter, and we're trying to find the equation of the circle. Now remember, the equation of the circle is going to be y, so I'm going to have the x minus h squared plus y minus k squared equals r squared. So that's your standard form of the equation of the circle. So basically, this is my center. So this one, when you're looking at your center, it is hk. So my h is 4. So I'm going to have x minus 4 squared. And my k is 5. So I'm going to have y minus 5 squared is r squared. And my diameter is 8.2, which means my radius is 4.1. Okay, so what I want is 4.1 times 4.1, because I want 4.1 squared, and that's going to give me 41 and then 164. So when I add those together, I'm going to get 1 and 8 and 6 and 1 with 2 decimal places. So 1681 is the square of the radius, and we got that one right. Okay. And lastly, last problem on this section. We have a circle equation, and now we're going to graph with the center and the radius. Okay, so here is my x plus 2, but then when I look at the center, that's going to be what? Since this is a minus, back in my original formula, remember it was an x minus an h, so the h value is actually the opposite of that sign there. So my hk, my center, is going to be negative 2. And there's just a y squared. And it doesn't matter whether that y is inside or outside, or even if you have those parentheses. Because the y squared means that there's no k. K is 0. There's nothing with it. Okay, so k is 0. So I'm going to go to a center of negative 2, 0. And I've got an r squared of 100, which means our radius is 10. Okay, so when you're doing this on a test, you should show me center and radius and label those. Okay, so then I'm going to graph a radius of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm making this small here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is just an easy way to graph it, is to go 10 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then draw a nice circle, hopefully better than mine, through your grid. Okay, so now we're going to take this same one and we're going to put it on the graphing calculator just to see how that's done. And so remember, when we're putting something on the graphing calculator, we want to have y equals. So we're going to start by solving for y. We got y squared is equal to, now when I move this over here, it's going to become a negative x plus 2 squared, and then plus 100. Okay, and then I'm going to take the square root of the whole thing, and it's going to be a plus and minus. So I'm going to wind up with y equals, and I'm going to do plus or minus the square root of a negative x plus 2 squared plus 100. Okay, so we can either put that in like it is right now, or we can clean it up a little bit. So I'm going to clean it up a little bit just to make it a little bit easier to type in. So this x plus 2 squared, remember, when I have a binomial that I'm squaring, it's the first term squared. So I'm going to put a negative out here. And then this product, 2x doubled, is a 4x. And then the last term squared is a 4. Okay, but then I have a minus going through all of those, and then finally a 100. And the whole thing under the radical. So let's do one more step. So we got plus or minus, and then we got the nice little radical. Okay, so we've got a negative x squared. Okay, and then we've got a negative times a positive 4x. So it's a negative 4x. And then we've got a negative times the 4, which is a negative 4, plus 100 is plus a 96. Okay, so now we have something that we can actually put easier on the graphing calculator. You could have done it this way, but I just chose to simplify it before I stick it on. So now I'm going to take that equation. So go ahead and get that down on your paper, because I'm going to have to put this down. Plus or minus the square root of negative x squared minus 4x plus 96. Okay, so I'm going to plug that in. And remember, it's a plus and a minus. So I'm going to go over here, turn my calculator on, go over here, and I'm going to clear that one out. Clear that one out. So now I'm going to do the positive one first. So I'm going to do the square root of, and this is one way that you can graph it. I'll show you one more that we can do in a little bit. But let's do the negative x squared, and we need to square it. Okay, oops, I forgot to do my square root, and that's going to cause me a problem. So let's clear that out. Let's put in our square root, which is right here. Okay, and now I've got this whole thing. So negative x squared. Okay, I need a right arrow to get out of that. Okay, and then minus 4x. So that's a minus 4x. Okay, and then lastly is a plus 96. So plus 96. Okay, now that's half of the circle. So let's go down, and we need to close a parenthesis because we have the whole thing in a parenthesis. So we're going to close out that parenthesis, and that one should graph. We'll see it in a minute. And then we're going to do the same thing with the minus sign, because when we take a square root, we get a plus and a minus. So let's try that. So we're going to do minus, and we're going to put the minus out front, and then we're going to do the same thing, square root of, and we're going to get negative x squared, and then we're going to move out of that, and we're going to get a minus 4x, and then a plus 96, and we're going to close our parenthesis again. Okay, so we did the exact same thing. We just put a minus in the second one. So now when I graph them, all right, it's not going to be real round because of, oopsie, it didn't like that. Let me figure out what's going on, and I'll be right back. Okay, I found my problem. It was a very tiny one, but it was a one that was causing me to continue to go to error. And it was on my second equation, I had used a minus sign instead of a negative sign in front of the x squared. That little thing did everything. So now this is what you should get when you correct that problem, is a very oblong circle. Now remember, the circle is oblong because of the graph has not been squared. And we can square the graph manually by changing the window to be centered around the center of the circle. Okay, so that's the first thing I'm going to do, and then I'm going to show you how to square the circle using the calculator functions. So first, since our center of this circle is -2, 0, we're going to, and our radius is 10, we're going to move the radius of the circle around -2. So if I started at -2, like on my graph here, okay, to make my circle circular, I'm going to say, oh, I'm going to change my window to be, since that was -2 already, and then I'm going 10 more on the other side, I'm going to have my x be -12. Well, we'll go one past it, okay? So -13, and then I've got 10 over here, but they start at -2. So that would be 8 plus one more is 9. So I'm going to go -13 to 9 on my window on the x, and then on the y, since that's at a 0 for the y, then the y, I'm going to say it's going to go to 1 past 10 down, which would be -11, and then 1 past 10 up to be +11. So I'm going to change my window to reflect that, and I'm going to make sure that my x scale and my y scale are back to 1. Okay, so remember we changed it to 3 and 5. So that's why this is so wide, because our x scale and our y scales are different too. So we're going to go to our window, and we're going to change this to -13, and then on the right a 9, and then a -11, and then a +11, and oops, that was my scale. That's what happens when you can't see what you're doing. Okay, let's start that over again. All right, so -11, 9, and then this was my scale. That should go back to 1, and then -11, and then a +11, and then a 1. Okay, so this is what I should have. Okay, can you see that? So I'm basically putting my x scale and my y scale back to 1. So now let's graph it and see if we get something that looks a little bit better. Okay, it doesn't look quite circular, but it was better. Okay, so basically what's going to square that up better is the, because my window is not square in itself. Okay, so I could square my window in itself and make it a little better, but I can also go to my zoom feature, and I can go to z-square. Z-square squares my window. It's on your zoom feature. Okay, so now look how nice and round my circle is going to be because I used z-square. Okay, see, this circle is still going to be centered at -2, 0. Okay, and it's still got a radius of 10, but now it looks nice and round using that z-square function. Okay, that's one way to graph the circle. Now the other way to graph the circle is coming up next. Okay, I promise this is the last thing on this video. All right, so now the other way to do the circle, notice that I've cleared out my y equals, okay? This is definitely the easiest way to do it, But when you're solving, not every calculator has this function. So what I did before was I solved for y, and I used both the plus and minus options to get the circle shape. What I'm going to do now is leave this blank, and I'm going to go to second draw, and your draw is on your program button here. Second draw, and then I'm going to go down here until I get to 9, or you can punch in a 9, and not 9, yeah, 9, which is circle. And then when I click on it, since there's nothing else in there, it's going to look for parameters. Okay, and I have already done it here. I put the parameters before were -2, 0, and 10, because the circle that we are working on right now has a -2, 0 for a center and a radius of 10. So I'm just going to do it again. -2, comma, 0, because that's the y value of the center, and 10, which is the radius. And now when I hit enter, because it's already in the circle function, it's going to go graph me a very pretty circle that really looks, if you look at it closely, it's more like it's a many-sided figure, because you can actually see the little line corners on it, but it's as good as it gets on that feature of the calculator. So you can either do what I did before, which was solve for y and get a plus and minus square root function, or you can use this one for your graphing calculator. Remember that for your test, you will need to be able to graph a circle without a graphing calculator and with a graphing calculator. And this is Mrs. A, and we are done with 1.1, and I hope you have a wonderful time. Blessings!